of the vectors. Since you have learned that vectors need magnitude, appropriate unit, and direction for its complete description, so let us now give emphasis to it. For this topic, we have to represent a vector, define resultant vector, perform addition and subtraction of vectors, use Pythagorean theorem, find the resultant vector by component method. So, let's start with vector representation. An arrow represents a vector quantity. Thus, if we represent distance as d, displacement will be d with an arrow on top. Likewise, if we represent speed as v, we have to put arrow on top of it to represent velocity. So next, in graphing a vector, the length of the arrow is scaled to be proportional with the magnitude of the vector quantity it represents, while the direction of the arrow represents the direction of the vector quantity. So also, you need to remember these following directions: north, south, east, and west. For example, you are given a vector which is measured from east going to north. The direction will be north of east. Another thing, north and east directions are positive, while west and south directions are negative. So that is how you represent and graph a vector. Given this example, specify the direction of vectors A, B, C. We can now proceed in determining the resultant vector. What is resultant vector? Resultant vector is simply the sum of two or more vectors. There are different cases in finding the resultant vector. For the first case, two vectors acting in the same direction. If we are given 400 meters east and 200 meters east, the magnitude of the resultant vector will be equal to the sum of the two vectors. Thus, 400 meters plus 200 meters is equal to 600 meters. The direction will act in the same direction as they do. So, the resultant vector is equal to 600 meters east. For the second case, two vectors in opposite directions. If we are given 50 meters west and 340 meters east, the magnitude of the resultant vector will be equal to the difference of the two vectors. Since we know that west is negative and east is positive, thus negative 50 meters plus 340 meters is equal to 290 meters. We will take the direction of the greater vector. Thus, the resultant vector is 290 meters east. For the third case, two vectors acting perpendicularly. For this case, we are to recall what Pythagorean theorem states. If you remember this formula, that the sum of the squares of the two sides is equal to the square of the hypotenuse. Thus, we can say that from this figure, the resultant is equal to the square root of force 1 square plus force 2 square. So from the Pythagorean theorem, we can determine the magnitude of the resultant. How about the direction? Recalling the trigonometric functions, the cosine, sine, and tangent, the function tangent will help us to determine the direction, for we are given the opposite side and the adjacent side. Hence, to get the angle, you are to follow this formula. You have now the idea on how to solve for the resultant of two vectors. What if you are given 3 or more vectors? You have to learn one of the analytical method, which is the component method. A person runs 4 meters 40 degrees north of east, 2 meters east, 5.20 meters 30 degrees south of west, and 6.50 meters south. Find his resultant displacement. Given those 4 displacements, to illustrate, convert their direction first to angle measured from standard position, and that is from east. Resolve the given vectors into their x and y components. To compute for the x and y components, for x, use this formula. And for y, where d is the magnitude of the vector or the displacement and theta represents the angle. Following that, for each vector, you will have these results. Add the components of the x components and also the y components. For this will represent the x and y component of your resultant. Calculate the magnitude of the resultant by Pythagorean theorem. From the signs of the x and y component of the resultant, we can determine what quadrant the resultant lies. Knowing that for quadrant 1, we have positive and positive, quadrant 2, negative, positive, quadrant 3, negative, negative, and for quadrant 4, positive and negative. This means our resultant is on the quadrant 4, for x is positive and y is negative. So this will be south of west. To compute for its angle, we'll make use of the function tangent. Hence, the resultant is 6.55 meters, 85.09 degrees south of west. To summarize our discussion, you learned vector representation, adding and subtracting two vectors, finding resultant by analytical component method, following these procedures, getting the x and y components and its summation, finding the magnitude of the resultant by Pythagorean theorem, and determining its direction and angle. One application of this concept will be the parenteral administration. Why? In parenteral administration, we have different injection routes: intramuscular, intravenous, subcutaneous, and intradermal. So here, we consider the length of the needle and direction or angle of elevation of the needle from skin, depending on what route it will be administered. So, vectors are important to prevent infection and tissue damage. And now I think you are ready to take some practice exercises. So you may pause the video for a while to look at the given. For this topic, we have one value to be considered. It is very important for us to have patience in dealing with these problems. I am Princess Meneses of BS Pharmacy from Our Lady of Fatima University. Please view other clips of SPEEDinar to learn more about physics. Thank you.